We started on this problem on number 52, and I'll explain to you how this one is. It's really depth in thought that you got to take it to the next level in your thinking in it, and this is why I like it so much, is because of how much thinking you have to put in it. So we've got A and we've got B, and I almost made a mistake on B. I had to think about it for a second. That it slows down, so that means that acceleration actually acted on us. It increased the weight. That's why we felt the jolt. But so we're going to go part C. Now I'm missing my black pen. I don't know what I've done with it. Part C.
53 kilograms.
Yeah, it's 53 kilograms.
What page is this on?
4.2. Excuse me.
Thanks. Look.
You should have this.
No. We get ready to leave when you know this. He's in the middle of the thing.
You didn't have 53 kilograms?
Now, huh?
That was the beginning of the problem.
Where did we get to?
No,
Oh.
B. Part B.
Okay.
I didn't have any of this.
Alright, anyway, so part C, it speeds up at 2.0 meters per second while moving downward. So here's the thing, is it's kind of like you're on the 4th floor, you walk in the elevator, we're standing there. We press the button. We press the button to go down to the 1st floor. As soon as the elevator starts moving, it accelerates at 2.0 meters per second squared, moving downward. So it moves down. What do you feel? You feel heavier or lighter?
Lighter.
You feel lighter. Why? Because the elevator moved down. That was the platform you're standing on. It accelerated down.
Oh.
So whenever it starts to accelerate, what we have is our acceleration of gravity. And in this case, in terms of us, we're feeling lighter, so that acceleration is opposite of gravity. So for us, we're feeling gravity, but we've set down as negative, which means gravity is negative. So we're actually going to add the 2.0 meters per second squared here to get
Like 9.81 plus 2.
Negative
Yeah.
2.
So get negative 7.81 meters per second squared.
So gravity is negative.
Yeah.
Yeah. The gravity's going down.
I think that's why this class started going downhill for me, is when we started to deal with negatives.
So gravity is negative.
That was that
9.81.
evil laugh.
Yeah.
It's like,
So in this, that's our acceleration. So if we're going to find the force is equal to mass times acceleration, which is equal to 53 kilograms times negative 7.81 meters second squared, which will be equal to negative 413.93 newtons.
nice.
I got negative 413.4.
You got one?
Huh?
What'd you get?
Negative 413.4.
What'd you type in?
53 times.
There you go. Any questions on C?
Wait, that's it?
Yeah.
No tricks.
No.
That's something, alright, that's something bad coming.
Unless there's always
Listen.
something bad coming.
Listen, that's the next chapter. Don't you
See, told you.
But it's coming nonetheless.
pretend it's far off in the future.
No, because then it'll come up on me and be like a ninja.
So number 52, part D.
Blasting.
The elevator moves down at a constant speed. So, do we have an acceleration being added?
No.
No, because it's going at a constant speed. So in this case, acceleration is just gravity.
So will it always be gravity?
I can't say yes to that.
What we're doing with this, we said.
So we already did this part. And you type it in, you get 519.93 newtons.
Wouldn't it be the other one?
Why are they making us do it twice?
Because like part A is you're going up, part D is you're going down.
Okay.
Because direction doesn't matter in this case, it matters on the acceleration. And in part A, that acceleration is not adding anything to us because it's at a constant speed. It's the same thing for
So they're just
part D.
trying-
The elevators are they're going in opposite directions, but their acceleration of that elevator
It's the same.
is zero.
So they're just trying to trick you.
This is where it's one of those you really got to think about problems.
I also wasn't really here for the other day when you were like going
I
up
know.
and down and
Uh,
is that video posted or not?
yeah.
Okay. I'll have to watch this evening.
It posted this morning, I want to say about the third period.
Okay.
It posted, and if I haven't seen it yet,
Mhm.
it is coming.
Okay.
I think I got it scheduled for it to release. I also sent the answer key for that metric conversion sheet. That I did. And I'll walk through explaining why I got what I got.
Okay.
If there's any talk in that video about a quiz coming up or anything, ignore that. That's an old video.
Okay.
Alright, so let's look at E. Part E. Alright, so in part E, the elevator, it slows to a stop while moving downward with a constant acceleration of 2.5 meters per second. So, this is the part where we're going from the fourth floor to the first floor, and it's hitting right where we're at the first floor door, and the elevator is slowing down to stop. And it accelerates at 2.5 meters per second squared. Question, do you feel lighter or do you feel heavier?
Downward so you can feel lighter.
Lighter, but once you get closer to the bottom, you feel heavier.
You will feel heavier.
'Cause
Why
it
will
was
we feel
slowing down.
heavier? Is the elevator is coming at a constant speed and then it starts slowing down. You were still traveling at that speed.
Inertia.
So now you are pushing down harder on the scale. You feel a greater weight at that moment.
Whack.
Yeah,
So-
not good.
You say you are or not? Okay.
All
Think
right.
about when you ride on an elevator and you go from a high floor to a low floor. Whenever it stops, do you feel your mass increase? Will your weight increase? Do you feel heavier?
I mean, I guess.
Okay, because you're traveling down same speed. But then what happens is the hand stops. You want to keep going.
Because of
So
inertia.
you are pushing harder.
So it don't just slow down, it stops.
Yeah, you're looking and saying that.
Okay.
So is this similar to like with the L?
What?
Never mind, I don't know what I'm saying.
So, will we add it? Add the 2 point?
There you go. So it's going to be gravity and we're gonna add it, but we actually need to increase it to go in the same direction. So when we look at it, you're really gonna be thinking you're gonna subtract that out because it's going in the downward direction. So
But wasn't C going down too?
yeah, but it's speeding up. This one is slowing down. It slows to a stop. That tells you it's going opposite. So we get an acceleration of negative 12.31 meters per second squared. So we will get a force, mass times acceleration, which is 53 kilograms. Negative 12.31 squared. Multiply that out with a force of negative 652.43. Spoke.
Mr. Hall, have you ever watched Breaking Bad?
No.
I mean, you know that scene where he's like science, wordy dirt? You know where he's like he brings his kid, like that student in, and they're like talking about the thingy, and he's like, yeah, science. That's what you just reminded me of.
What about the S word?
Take my pen back. I hate that show. How's everybody doing?
I've begun to like this class again.
Good. Let's keep you like it.
Just as long as we don't have no tests, I'll be A-okay.
Yeah, I don't get tests.
I feel.
He gives quizzes.
I feel good about it until we ask for good and I don't. Like when you're doing it with us, I'm fine, but when I do it on my own, I don't get it right at all.
I know, that's the point of where education is. Alright, let's look at 53. 53 on the surface of a Mercury gravitational field is 0.38 times its value on Earth. What would a 6 kilogram mass weigh on Mercury?
So how do you calculate gravity on other planets?
Yeah, there's a chapter that we're going to do that you're going to calculate gravitational force between objects.
So we still go to 4.
Gee, thanks. You made me feel great about it.
It's too hard.
What is it?
With the gravity, do you still want us to go to 4 decimals where we're adding this extra little bit, or do you want us to get
Absolutely,
down
4
to
decimals.
Okay.
Alright, so A, we got a 6 kilogram mass. And we're just trying to find its weight, so the force of gravity is equal to mass times gravity. But the key to this is the gravity of Mercury that we're looking at. So we had to find the new gravity value, and it said that it is 0.38.
That's the gravity?
Yep, 0.38 times that of Earth's gravity, which is,
Why are we times it?
because we have to find the gravity of Mercury.
Does it say in the question times by?
No, you have, it tells us it's 3.38 times its value on Earth,
Okay.
but you have to understand you got to figure it. So we find the value to be 3.7278 meters per second squared. So now we're going to look at the force of gravity is equal to the mass, which is 6 kilograms, times that gravity value we just calculated. So we find the weight to be 22.3668 newtons. Boom.
Would it be F equals, or does that matter?
I just did F sub G.
Now, was that A?
That was part A. Yeah.
You know how before when I entered it into my calculator that I might be like a decimal place that's one above the damn float. Like, you know how you take the answer that you got and you divide it, but what if you round to the nearest fourth decimal place over it, and there's like, 10,000th off or something?
That's okay.
Mr. Hall,
Yeah.
I've been meaning to ask this for a long time. What does the F sub G mean?
Yeah.
Force.
Like why
Force
sub
of
G?
Right.
It's force of gravity.
Okay. So the force of gravity equals mass times gravity?
Wait.
On our quiz, if we don't put the
Wow.
If you don't put what?
if we don't put the letters like F equals or FG equals, and we just circle the number that we got.
Like force of gravity.
I'm gonna give it to you, but it's gonna be hard to follow. Like, if I give you a problem like I did,
No, I know that, but I was using F instead of FG equals.
well, that's fine. As long as you know what you're solving for. Part B.
So FG is weight.
Yes.
Okay. That helps.
If the gravitational field on the surface of Pluto is 0.08 times that of Mercury, what would a 7 kilogram mass weigh on Pluto? So now we got a new mass, 7 kilograms, and we got to find a new gravity because gravity on Pluto is equal to 0.08 times the mass on Mercury, 3.7278 meters per second squared. And we'll find it to be 0.2982 meters per second squared. So now we're trying to find the weight, so it's force of gravity, which is equal to mass times gravity, so 7 kilograms times that acceleration we just calculated, 0.2982 meters per second squared. I get 2.0876 newtons. You got something a little different, it's because in my calculator I left this whole thing.
Yeah. Okay.
I got 7.4.
Yeah, that's because I left this whole thing in here, this 0.298224. I just used the answer times 7. Yeah, John. Woo. There we go. You're number 53.
Are we done 54?
Thanks. Any questions? We gotta wait on 54.
Oh, air resistance, isn't it? Oh, never mind.
That's not why we gotta wait on 54.
Why?
Because on 54, I'd have to write some formulas on this paper. that I'm not gonna write on this paper right now.
Okay, please don't.
Air resistant.
No, it's not. Yeah. It's not
Wait,
fair.
what was I gonna do? Wait, what's it called?
They blow our minds, don't they?
All right. Let's move to 60. Well, 60 is a good one too.
Can we do 60? We got it.
You want to try it yourself?
Oh, I was asking if you had to do the formulas for it.
Let's do this for ourselves and see how we
This
do.
one's just forced.
Oh,
All right, I'll give you an opportunity. Give 60 a shot.
What page?
115.
Are we doing 60?
Yep.
This one.
hot in my room, brother.
And mine stays hot. Mine gets pretty hot in the morning.
Can we work on this together?
Yeah, that's fine.
So, am I overlooking this? Would it just be gravity?
Yeah, that's what I thought, but like the first one would have to be positive and the second one would have to be negative because the second one's pushing down and the first one's pushing up.
That's what I
If we
thought.
want to establish gravity as our negative.
We're on 60, ain't
Is that what it is?
Yes, and then I got this for part B.
Stick with that logic and hope it works.
What did you get for part B?
Negative 9.81.
We're supposed to be finding the force, so we have to have newtons, right?
Let's look and see if that's what that's. What is the force? Yeah.
That's what is the force, so you have to take the,
So, oh, yeah, okay.
yeah. After you get both A and B, tell me what you got.
So for A, you get 58.86 newtons.
That's what I got for B. I got negative 58.86 newtons for B.
For A, I
Yes.
got 68.67.
I agree with that.
Oh, okay. So, 68.67,
68 point what?
67,
Yeah.
okay.
I'm taking a guess and I'm gonna say we've done this wrong, because he looks very confused by what we're doing.
Hold on, wouldn't it just be the opposite because the 6 kilogram block has to be able to hold up the 7 kilogram block? So the forces would cancel out since they're not moving anywhere?
I wonder how the table plays into this.
Yeah, but they're still exerting force on one another. It
Exactly.
would be equal, but it would still be, the
Exactly.
force would be pushed down. You'd still have to,
It'd be like negative 68.67 instead of,
it? I got
Positive.
I got negative.
yeah.
I got negative 68.
no, it'd have to be positive because it's pushing up on the 6
You-
kilogram block that's sitting, that's resting on top of
We
it.
can establish different directions as long as we align our
Well, I'm
directions
putting
with it.
gravity is negative because it's pushing down.
Okay.
Yeah.
Then the first one, then A would be negative 68.67.
How do you get that it would be negative? Because
Because
it's
it's
pushing
pushing
back up.
Can't you like make it negative if you want to though? Like,
Yeah, you can make direction and whatever whatever the correct one, as
But
long
you
as
want to-
everything else goes along with it.
Okay, Connor, I still don't get what you're saying with it would be
Because
negative.
the 7
The 7 is resting below it and it
It's
is
not
being pushed, but
negative.
it's having to push up.
Which means it's
It's-
not negative.
Exactly, that's what I'm saying, it would be positive.
Okay, a negative times a positive is a negative.
How are you getting, hang on.
Logan.
but if,
No, because it would be exerting the 9.81 meters at least back up on it, which would be a positive. The gravity would be the second one, that would be negative. We would establish that as a negative.
Okay.
So that would mean the first one
It
would be
doesn't matter
positive.
though, because.
Yes, it would, because it's exerting the 9.81
Right,
negative,
you've
and
established-
that's putting up the 9.81 positive.
Right. You've established that gravity is down for you, right?
Yes.
Okay, what if I establish that gravity is up instead?
Okay, and say that.
Alright? That's what we're trying to say. Is that,
we're not
Then
getting
say
that.
is that the sign doesn't. As long as everything else that we
All
do
that
with
for
that
a
sign.
simple.
I understand, no, I get that.
That's what I've been trying
We
to
was
say.
aligned at
that.
first, and then you confused me by saying
Okay,
back, like,
just say
pushing
that.
back up is negative and everything else.
Everybody's gonna think I'm
And
so
you can tell
somebody. Okay, anyway, so
So Mr. Hall, when will the damage be done to my road?
next year.
Oh,
Well, actually, there ain't no damage to it. The damage has already been done. You got a 0 live rates right now.
Well, true. When will
You can only
either
go
stay
up
at
from here.
0 or come up a little bit.
You can only go up from here.
That's true.
Do we have the right thinking on this problem at least?
Let's just do it together.
All right, anyway. So number 60. 6 kilogram block rests on top of a kilogram block, which rests on a horizontal table. Here's my table.
I knew the table had to mean something.
There is 7 kilogram block. Say hello.
Hello, 7 kilogram.
And here is 6 kilogram block. This is not a 2-tier cake.
I wish. I'm hungry.
Alright, so in this case, A, what is the force, magnitude, and direction exerted by the 7 kilogram block on the 6 kilogram block? And B, what is the force? Well, let's just look at it. So I'm trying to figure out what force this block is putting on this block. So whenever we look at that,
Don't we have to find that force? I thought we're.
kind of, technically, yes. But in this, we're going to deal with a good old-fashioned 3-by diagram. So we're going to look, I'm going to move my 3-by diagram out here. This is the middle point between the two. So here's what's going on. What forces is acting here?
Gravity.
Okay, force of gravity. I have weight coming down. Okay, now here's the thing. Weight's coming down. Force of gravity, but what is that the force of gravity of? What's that the weight of?
That 6 kilogram block.
The 6 kilogram block. So I'm going to put a little 6 here, so that I know that. Now, what other force
The normal force.
is here? The normal force.
To keep the 6 kilogram block from busting through the
The
center.
United States.
Exactly. So the normal force, which is the force that's just acting upward,
F is for fancy.
whenever we do this, oh, that's supposed to be capital. We have the normal force. That normal force is what is holding it up. The normal force can also be said to be the force that the surface is exerting on the 6 kilogram block to keep it up. And what is the surface that's exerting that force?
The 7 kilogram block.
The 7 kilogram block. So we're trying to find these two. You guys have kept going back and forth. I'm pretty sure you guys are spot on with this. Because every one of y'all are like, wait a minute, this one's pushing this way and this one's pushing this way. So it's really the same thing, but the signs are different because they're just in opposite directions.
Yeah.
And that's exactly what you're looking at here. It's exactly what we have to figure out.
Okay.
So in this case, we're going to do the first thing. Let's figure this out. This will be, what is the force magnitude? This is part B. What's in purple. And I'm just figuring out what part B is because then I can just throw in part A.
Yeah.
So in this case, we have force of gravity. So that's mass, which is 6 kilograms, times gravity, which is 9.81 meters per second squared. And in this case, you can choose whether you want it to be positive or negative. Or you can get really fancy with it and you can say that this force is upward and this force is downward. Doesn't matter. You guys kept arguing back and forth, but what do y'all want to do? Let's solidify what our
Do
plan is.
gravity down.
Solly Hicks,
Okay,
Angela
gravity down.
Kinzer, Ashlyn Hatfield, Spencer Koenig, Jordan England,
So down
Matthew
is negative.
Daniels,
Yeah.
Alright, so down is
Kenzie
negative,
Bledsoe,
which means gravity is negative.
Adriana Brown, Hunter Blankenship, Zion Lusk, Heath Martin, come to the office.
Is Heath Martin in virtual?
So in this,
Mr. Hall, why wouldn't 6 kilograms would be negative if it's on top of it.
Cause that's just the mass of it.
Cause it's just how.
Yeah, it's just mass. Mass doesn't have a direction.
It's just unique.
Mass is just mass.
So I get negative 58.86 newtons.
Mass and weight is different.
So that's part B.
Mm-hmm.
Now flip, let's go to A.
Mm-hmm.
Because this is the force that the 7 kilogram block is exerting on the 6 kilogram block. It has to be equal but opposite force of gravity. So this will be 58.86 newtons.
Huh?
Thomas, you were initially correct whenever you were like 58.86.
Mass is
But-
power.
So
Me
they're
and,
both
me and Logan did for
the
the
same
7 kilogram
force
block
because neither one of them
instead
is
of.
They're not moving.
So it's the same exact force.
Exactly, but opposite. They have to be opposite in direction.
So this.
Your force can only be.
Okay,
equal.
never
How
mind
did
though.
you even
Yeah.
The
bring
surface
that?
isn't
Listen
acting
to
force
Yeah, I got it now.
Yeah.
like gravity is.
The normal force is an
No, normal, yes.
What is it, Chris?
How did you get the green part though? Like FG6?
It has to be opposite of FG6 because I named force of gravity as a force of gravity of 6 kilogram block. They have to be opposite. The reason is that it's not moving in the y direction.
So we wouldn't even have to. Why wouldn't you do that one? Like you did the 6 kilograms times the negative 0.81.
You can, but in that case, you have to look and know that they're opposing.
But I didn't get that.
All it is you flip the
There's
sign
not
of
really an
gravity.
acceleration to calculate with that. The reason I can find that there's an acceleration on the second one is because I'm trying to find the weight, which is force of gravity. So we have an acceleration of gravity there. The reason I can find the normal force, the top one, is because it's opposite of force of gravity. Nothing else is acting on it. And I know that the box is not moving through, falling and crashing. So in that case, I know that it has to be the same exact value, but opposite of the sign. This is a lot of foreshadowing of thought. Literally, this chapter gets you thinking so that we can get you into 2 dimensions with forces.
I'm fine with one.
Questions?
Can we just like stop doing this?
Let's have tech day tomorrow.
Tech day.
No, no tech day.
Tech day, please.
Okay,
Worth a shot.
so let's jump in. Let's do 54 now.
Oh, man.
All right, number 54, a 65 kilogram diver. So I'm going to take that mass.
I'd like to take a moment to congratulate our November Students of the Month. They are Ben Mullins, Madison Redden, Tanner Walls, Cheyenne Jenkins, Elijah Ellis, Aaron Cook, Connor Lee, and Joshua Poe. Please come to the cafeteria so we can get a beautiful picture of you folks. Congratulations.
All right, so 65 kilogram diver jumps off a 10-meter tower. So changing y displacement is 10 meters. Assume the air resistance is negative. Just forget it. A.
Colton
Find.
Reese West to the office.
Why do you have a triangle?
Let's
Change
Yeah,
displacement.
that's a delta, not a triangle.
It's a triangle, Connor.
That's what down.
If this is like calculus, then I'm won't be hurting.
Find the diver's velocity when the diver hits the water. So in this case, we're looking at part A. The diver's going to start with an initial velocity in the y direction of 0 meters per second. So in this case, we look at A, find that velocity. So we at this point do not know what time is. So this is what I'm going to do. I'm going to jump for
What are we finding here?
final velocity when he's hitting water. So final velocity squared is equal to initial velocity squared plus 2 times acceleration times y final minus y initial. So in this case, velocity final is equal to the square root of
Hold on.
So then if we're going to look at the square root of the initial velocity, which is 0, so it's gone. So 2 times acceleration, we're in the y direction, so we're dealing with gravity. I'm going to make down positive. Everything's moving down. I'm making down positive so I can just deal with positive numbers. So 9.81 meters per second squared times y final minus y initial, which is 10 meters.
$14.007.
In this case, I end up with 14.0071 meters per second. Questions?
No, sir.
Okay, we got part B, but we'll solve that from tomorrow. Please make sure you put my calculators back, and you are dismissed.